Hello dear students, welcome to the channel and welcome to the second class of this playlist in which we are discussing the subject instrumentation and sensors. In previous class, we have discussed about measurement in basics. We have introduced ourselves with measurement, what is a measurement and how it changed forms by different by time. Today we are going to discuss some of the applications of measurements, and we are also going to discuss how it can affect our daily life, right? So see, in present day applications of measuring instruments, it can be classified in three major areas, right? First, regulating trade. Second, applying instruments that measure physical quantities like length or volume or weight or mass in terms of standard units. And third, okay, we are going to discuss third one later on. Just right now, focus on these two right now: regulating trade and applying instruments that measure physical quantities such as length, volume, mass in terms of standard units. So the particular instruments and transducers employed in such applications are included in the general description, which we are going to see in the second part of this book. And this measurement application, let's see here, and monitoring functions, it is used. So this provide information that enables human beings to take some prescribed action accordingly. For example, the gardener uses thermometer to determine whether he should turn the heat on in his greenhouse or open the windows if it is too hot, right? The regular study of a barometer allows user to decide whether he should take his umbrella or he can walk off if he is planning to go out for a number of hours. So there are multiple applications, right? So another one is in the chemical process. For instance, the progress of chemical reaction is indicated by measurement of temperature and pressure at different points, and such measurements allows the operator to take correct decisions regarding the electrical supply to heaters, cooling water flows, wave positions, etc., valve positions, etc., right? And you might have heard about the automatic feedback system or closed loop system in some of the applications. See, we have shown the closed loop system here. You can see this, right? This is the, you can call it automatic feedback control or closed loop system. It is a simple temperature control system in which the temperature TA of the room is maintained at reference value TD. Okay, so this is the reference value, TD is the reference value, TA is the actual value. Let me use the highlighter. Let me, yeah. So this TD is the reference value, TA is the actual value. Okay. So the value of controlled variable TA as determined by the temperature measuring device is compared with this reference value, this TD. And the difference, which is called E, the error, TD minus TA, is measured, right? And that difference is applied as an error signal to the heater. See, we are sending the error to the heater. The subtraction of TD and TA, we are sending it to the heater. So the characteristics of a measuring instrument used in any feedback control system are fundamental importance to the quality of control achieved. And the accuracy and this resolution After that, the heater will modify the room temperature until the value of Ta becomes equal to Td. And the characteristics of measuring instruments used in this feedback control systems are fundamental importance to the quality of control achieved. The accuracy and resolution with which the output variable of a process is controlled can never be better than than the accuracy and resolution of the measuring instruments used. So it is very important principle, and often it's not good enough to use in automatic control system. So we need more for refurnishment, but it gives you basic idea, right? Now let's see what are the elements of the measurement system. So a measuring system exists to provide information about physical value of some variable measured. In most of the cases, in simple cases, the system can consist only single unit that gives an output reading or signal according to the magnitude of the unknown variable applied it. But in more complex systems, measuring system consists of several separate elements, which you can see in this image. See, we have sensor, we have variable conversion element, we have signal processing, then output gets measured, signal gets transmitted, then we use measurement at different remote points, and signal presentation takes place, or the recording signal recording takes place, and then we get the output. So that's the complex one, right? So these components might contain within one or more boxes, and the boxes holding individual measurement element might be either close together or physically separate. The term measuring instrument is the commodity used to describe measurement system, whether it contains only one or many element, and this term will be widely used throughout this text. Okay, so the measuring instrument, please be aware about this term. Now, first element in the measuring system is the primary sensor. You can see here, and that's what today's point is. We are going to discuss what is a sensor and how we can like use the sensor, how it is useful to us. So this sensor gives an output that is a function of the measurand. Measurand is the input applied to it, and for most but not all sensors, this function at least approximately linear. So some examples of primary sensors are a liquid in gas thermometer, or a thermocouple and a strain gauge. And in case of mercury in gas thermometer, the output reading is given in terms of the level of mercury. And so this particular primary sensor is also complete measurement system in itself. But in general, primary sensor is the only part of a measurement system, it's not the whole system. So the type of primary sensors available for measuring a wide range of physical quantities, we will be studying about them in the next chapter. Now, variable conversion elements are needed where the output variable of a primary transducer is in unconventional form and has to be converted to a more convenient form. For instance, the displacement measuring strain gauge has an output in the form of a varying resistance. The resistance change cannot be easily measured, and so it is converted to a change in voltage by a bridge circuit, which is a typical example of a variable conversion element, by the way. And in some cases, the primary sensor and a variable conversion elements are combined, and this combination is known as a transducer. If you've studied transducer in any of the mechanical classes, so you would know what transducer is. It converts one form of energy to another form of energy. Then we have the signal processing element. You can see here, this is my transducer, this is my signal processing element, right? This is the transducer. Let me write to you here, this is my signal processing element. So signal processing element exists to improve the quality of the output of measurement system in some way. A very common type of element for signal processing is electric amplifier. We all have seen amplifiers or mics in mics, which applies the output of a primary transducer or variable conversion element, and thus it improves the sensitivity and resolution of the measurement. And this element of a measurement system is particularly important where the primary transducer has low output. For example, thermocouple has very low output, right? Only few millivolts. And the other type of signal processing element are those that filter out induced noise and remove mean levels. If you know about image processing, you would know about it. But in some cases, in some devices, signal processing is incorporated into transducer, and which is then known as transmitters, right? When signal processing is also incorporated in the transducer, we call it transmitter because it also transmits the signal, right? Except for these three, what do you see, right? Except for these three, some measurement systems have one or two other components. Firstly, to transmit the signal and to some remote point, and secondly, to display or record the signal if it is not fed automatically into the feedback control system. So signal transmitter is needed when the observation or application point of output of a measurement system is some distance away from the site of the primary transducer, and sometimes this separation is made solely for purpose of convenience, but more often it allows it follows from the physical inaccessibility or environment instability of the site of the primary transducer for uh, mounting the signal presentation and recording unit. So the signal transmitter element has traditionally consisted of single or multi-core cable, which is often screened to minimize signal corruption by including electrical noises. But now we are using fiber optics. So fiber optic cables are being used in ever increasing number of modern installations, and in part of that low transmission loss and imperv- uh, imperv- um, impervisionness to the effect of electrical and magnetic fields. The last optimization element that is uh, used in the measurement system is the point where the measured signal is utilized. In some cases, the element is omitted altogether because the measurement is used as a part of automatic control scheme, and the transmitted signal is fed directly into the control system. In other cases, this element is measurement system takes the form either of a signal presentation unit or signal recording unit, and these takes many forms according to the requirement of the particular measurement application. Now let's discuss the final topic of today, the way to select the appropriate measuring instruments. How do we do it? So starting point of picking up the right instrument to use for measurement of the particular quantity in the manufacturing plant or other system is the specification of instrument characteristics required, right? So what do you see first? You see specifications of the instrument characteristics required, especially parameters like the desired measurement accuracy, resolution, sensitivity, dynamic performance, precision, all that. And we are going to learn that as well. So it is also essential to know the second one. The second one is environment conditions that the instrument will be subjected to, because what happens, some conditions will immediately either eliminate the possibility of using certain type of instruments or sensors, or else will create requirement for expensive protection of instrument or additional gears accessories. So it should also be noted that the protection reduces the performance of some instruments, especially in terms of their dynamic characteristics, like sh- sheath protecting thermocouples and resistance thermometers reduce the speed of the response, right? So we don't use it. Provision of this type of information usually requires the expert knowledge of of personnel who are intimately acquainted with the operation of the manufacturing plant or system in question. Then a skilled instrument engineer having knowledge of all instruments that are available for measuring the quantity in question will be able to evaluate the possible list of the instruments in terms of their accuracy, cost, sustainability for the environment condition, and thus they choose to most appropriate instrument. Then one more thing to consider, that your sensor or your instrument should not be very insensitive, right? So uh, although this requirement is often difficult to meet because cost and the other performances are also considered, but the extent to which the measured system will be disturbed during the measurement process is another important factor in instrument choice, right? So for example, significant pressure loss can be caused to the measurement system in some techniques of flow measurement. So the instrument characteristic discusses the next chapter that we are going to see, and we are going to discuss about the technicalities of it. Generally, the better characteristics, the higher the cost. That's the scene. And even though in comparing the cost and relative suitability of different instrument for particular measurement, the consideration of durability, maintainability, and the consistency of performance are also very important, because the instrument chosen will offer will often have to be captured or capable enough to operate for a long time without the degradation of the performance and without high maintenance cost. So the initial cost of the instrument often has a low weighting in their evaluation exercise, and most of non-professional people buying instrument does this, get stuck on this issue. They see a cheaper product, they buy it, but it holds very less importance in the bigger picture. One more thing that is cost is very strongly related to the performance of an instrument as measured by its static characteristics, the increasing the accuracy or resolution for an instrument. For example, car can only be done at penalty of increasing the manufacturing cost. Instrument choice therefore proceeds by specifying the minimum characteristics required by a measurement situation and then searching for manufacturers catalogs to find an instrument whose characteristics match those requirements. Then we come to the purchase cost. Other important factors in the assessment exercise are installation durability and the maintenance requirements. Assuming I have a 10,000 pound to spend and one would not spend 8,000 pounds on new motor car whose projected life was 5 years in a car of equivalent specification with a projected life of 10 years was available at 10,000 pounds, right? And likewise the durability is important as well. The projected life of instrument often depends on the condition in which instrument will have to operate, so the maintenance requirements must also be taken in account as they have cost implications. So what is the general rule to buy an instrument? So the general rule, a good assessment criteria is obtained if the total purchase cost and estimated maintenance cost of instrument over its life are divided by the periods of expected life. The figure obtained is thus a cost per year. However, this rule becomes modified where instruments are being installed on the process whose life is expected to be limited. But what happens sometimes in manufacturer plant, particular model of car can be taken, right? So the total cost of my instrument can only be divided by the period of the time that the instrument is expected to be used for, unless an alternative application or alternative use for the instrument is uh, that instruments use pops up at the end of this period. So if I want to summarize the whole thing, is the instrument choice is a compromise between performance characteristics, ruggedness, durability, maintenance requirement, and the purchase cost. In order to carry out such an evaluation properly, the instrument engineer must have a wide knowledge of the range of instrument available for measuring particular physical quantities, and he or she must also have the deep understanding of how instrument characteristics are affected by the particular measurement situation and operating conditions. So we will keep today's class till here. We will continue our next class from here only. If you have any doubts or queries, feel free to mention them in the comment section below. I will be seeing you next time. And thank you very much for listening. Goodbye for now.